I hope all of you are doing good. Let's start today's chapter, linear equations in one variable. In earlier classes, we have learned the solution of equations that had integer coefficients and integer solutions. In this chapter, we shall deal with equations involving rational numbers as coefficients and their solutions. We shall also solve some word problems by first converting them into equations and then find the solution of these equations. Let us recall some of the terms we use in the solution of linear equations. Equation: a statement of equality which contains one or more unknown quantity or variable, that is literals, is called an equation. Example: 3x plus 5 is equals to 10 is an equation in one variable, and x plus y is equals to 3 is an equation in two variables. Here x and y are two variables. X plus y plus z is equals to 40. This is an equation in three variables because x, y, z, these are three variables. Okay. Variables. What are variables? The literal numbers are called unknowns or variables. Example: these are the variables. Okay. Solution of linear equation: any value of the variable which makes the equation a true statement is called a solution or root of the equation. For example, verify that x by 5 is a solution of the equation 4x minus 3. 4x minus 3 is equals to 17. Okay, value of x is given, which is 5. Let's substitute the value of x here, minus 3. 4 into 5 is 20. 20 minus 3 is what? 17. Okay, this is LHS and this is RHS. So, LHS is equals to RHS. Okay, that means x is equals to 5 is a root of the equation. Okay, next, solving an equation. Solving an equation means determining its roots, that is determining the value of the variable which satisfied. Rules for solving linear equations in one variable. Let us recall the rules for solving linear equation in one variable. They are: number 1, same quantity can be added to both sides of an equation without changing the equality. 2, same quantity can be subtracted from both sides of an equation without changing the equality. 3, both sides of an equation may be multiplied by the same non-zero number without changing the equality. And 4, both sides of an equation may be divided by the same non-zero number without changing the equality. Example 1, let's do it. 1 by 4 x minus 3 by 4 is equals to x. So, what will we do? We will add 3 by 4 to both sides. 1 by 4x minus 3 by 4 plus 3 by 4 is equals to 6 plus 3 by 4. Okay. 1 by 4x is equals to 4 is the LCM. Okay. 24 plus 3. So, 1 by 4x is equals to 27 by 4 and x is equals to 27 into 4 by 4. So, 4 goes, x is equals to 27. So, this is the answer. Okay. Transposition method for solving linear equation in one variable. In certain equations, the two sides of an equation contain both variables and constants. Okay. And in such cases, we transpose the terms containing variables from RHS to LHS and constant from LHS to RHS. So, some stops are involved in transposition. Number 1, obtain the linear equation. 2, identify the variables and constants. 3, simplify the LHS and RHS to their simplest terms. 4, transpose all terms containing variables to the LHS and all constant to the RHS. 5, while transposing, signs of terms will change, negative becomes positive and vice versa. Remember this, okay? Solve LHS and RHS to the simplest form. And 7, obtain the value of the variable. For example, let's do this example. 7x minus 4 is equals to 5x minus 12. Okay. So, what will you do? 7x, you will bring or you will transpose 5x to LHS. Now, you will change the sign of 5x minus 5x minus 12, and then we will transpose 4 to the right side and it will become plus 4. 7 minus 5 is 2x minus 8. X is equals to minus 8 by 2, that is minus 4, right? Exercise 16.1, solve the following equations and check the result. 5x minus 8 is equals to 2. 5x is equals to 2 plus 8 and x is equals to 5x is equals to 10, x is equals to 10 by 5, that is 2. Okay. Now check. LHS is what? 5x minus 8. Substitute the value of x, that is 2. 5 into 2 minus 8. 5 into 10 minus 8 is 2, which is equals to RHS. Okay, that means your answer is correct, right? Next, applications of linear equations to practical problems. In this section, we shall deal with the formulation and solution of some practical problems. These problems contain both known and unknown quantities. A word problem is first translated in the form of an equation containing known and unknown quantities, and then solve it as we had solved an equation in one variable. Thus, the process of solving a word problem involves formulation and solution. The following steps are followed to solve a word problem. Number 1, read the problem carefully and note what is given and what is required. 2, denote the unknown quantities by variables like x, y, z, etc. 3, translate the statements of the problem into mathematical statements. 4, form the equation using the conditions given in the problem. 5, solve the equation for the unknown. 6, check whether the solution satisfies the equation. Now, following examples will illustrate these steps. Example 1, one number is 6 times another, and if their sum is 56, what are these two numbers? So, let the first number be, let the one number be x. Other number is what? Other number is 6 times another, that is 6x, right? And sum of these two numbers is 56. So, now we have formed the equation. Now, it's time to solve this equation. X plus 6x is 7x is equals to 56. X is equals to 56 by 7, that is 8. So, one number is 8 and another number is what? 6x, that is 6 into 8, 48. Okay. So, one number is 8 and another number is 48. Okay. Let's do exercise 16.2. By adding 11 to twice a number gives 61. Find the number. Okay. Let the number be. We don't know the number, so we will let the number be x. Okay. Now, read carefully. By adding 11. By adding 11 to twice a number, means twice of this number, we get 61. So, 2x is equals to 61, then minus 11, 2x is equals to 50, and x is equals to 50 by 2, that is 25. So, the number is 25, right? Things to remember. Any value of the variable that satisfies the given equation is called a solution or a root of the equation. 2, the equality of an equation is unchanged if we add the same number on both sides of the equation. 2, subtract the same number from both sides of the equation. 3, multiply both sides of the equation by the same non-zero number. 4, divide both sides of the equation by the same non-zero number. 3, by transposing a term, we mean changing its sign and taking it to the other side of the equation. 4, in order to solve a word problem, we denote the unknown by some variable and translate the statements of the problem step by step into a mathematical statement or equation and solve for the number. Students, I hope you have understood this chapter. Now, do practice of the remaining questions.